Okay, so this unit is wrapping up our derivatives. It's application of derivatives part 2. And so we have a few theorems that we're going to start with. And so it says in the previous unit we investigated heavily how to locate relative extrema of a graph. In pre-calculus we talk about the difference between relative and absolute extrema. So make sure we want to understand the difference between that. Relative extrema points are just like the higher low points in that part of the graph, like the hills and valley. Absolute extrema are the biggest value, right? So I'm going to try to write this really small here. Relative extrema points, relative max and mins, are where graph changes from increasing to decreasing or decreasing to increasing, right? It's hills and valleys in your graph. But absolute extrema, the absolute max and min, are the highest and lowest points on the graph. Okay, so relative extrema is what we've been finding. Absolute extrema is the highest or the lowest. So let's look at a few things to kind of see if we can get to this theorem called the extreme value theorem. So it says, picture below are the graphs of f and g. Answer the questions about these two functions. So for the graph of fx, identify the coordinates are the relative extrema. So just looking at this graph, relative extreme point, we would have a relative min at -3, 0. We would have a relative max at the points -1, 3. And another relative min down here at 2, -6. It says on the domain of f, what are the coordinates of the absolute extrema? Well, what is the lowest point on this graph? So the absolute minimum would be the lowest point on this graph, and the lowest point would be right here, and that would be at the point 2, -6. So notice that relative min is the same as the absolute min. And what about the absolute max on this? Well, there would be none, right? No absolute max, because is there a highest point on this graph? No, because the domain keeps increasing, right? Like the domain keeps going forever. So I'm going to go over here before we go to the bottom here. Look at this graph. Definitely not a polynomial. It's kind of pieced together here. But it says, what are the relative extreme points on this graph? Well, we would have a relative max at turning point here, right? It's changing from increasing to decreasing. So that would be at -1, 4. That would be the only max because those aren't max. And the relative min, there's more than one, would be at -3, -4. That would be right here. And at 3, 2. And what about on this one, if I say find the absolute max and min? The absolute max would be the highest point on this graph. And the highest point on this graph is right here at the endpoint, would be at 6, 5. And the absolute min is at this same minimum here, which is -1, 4. So it says, on the domain of the given functions, did the absolute extrema occur at the function's relative extrema? And the answer to that is sometimes, right? Sometimes it can occur at that point. And so sometimes absolute extrema are equal to relative extrema, but not always, right? Because we can look at these examples and see examples where it wasn't always true. So look at the next one. It says, are these the same thing? These are different graphs, yes? Or they're the same graphs? They're the same graphs. It says, what are the absolute extrema of f? Oh, okay, they're different intervals here. Okay, I got you. So from -2 to 3. So only from here to here, right? I'm going to actually change it to this. -2 to 3. So only this part of the graph, what would be the absolute extrema? So absolute max on this interval here, what is the biggest value? It's right here at this relative max, right? Is at -1, 3. And the absolute min is at the lowest point here, which is 2, -6. And if we look at this one, it says on the interval -4 to 1, so only from -4 to 1, so that would be from here to here. What is the highest and the lowest points there? Well, the absolute max is now this endpoint here, right? That's the highest point. So that would be -4, 5. And the absolute min, I think, is the other endpoint at 1, -3, I think. And we could do the same thing over here, again, restricting our domain from only -4 to 5. So from -4 to 5, what is the lowest point on that graph? Well, the absolute min is this relative min right here at -3, -4. And the absolute max would be the highest point on the graph. And there's actually 2 on that one, because this point and this point are both the highest. So it's both at -1, 4 and 5, 4, because they both have the same y value on there. And then look at this. If I say from -2 to 6, hopefully you're getting the idea here. The lowest point is that endpoint. So the min is -2, 0. And the highest point is here at 6, 5. So it says when the domain is restricted, at what 3 places can the absolute extrema exist? So where did we see it? Well, one, we saw at the endpoints, right? So it could be at the endpoints of the domain, at the endpoints of the interval. Where else did we see it? And if I would kind of say, I almost want to say just at a turning point, but let's think about calculus for a minute. It definitely could occur like at the max and mins, the relative max and mins. So that would be where the derivative equals 0 of a function. And also we saw it could be at these sharp corners too. And sharp corners are not differentiable. So the third thing that they want you to say is where f prime of x is undefined. I think I would have put those as one thing, but since it says 3 things, we're going to spread it out. Where the derivative is equal to 0 or is undefined. That leads us to the extreme value theorem. So the extreme value theorem, we haven't had a theorem in a while, but it's really important that we write it out. So it says, the if part, really important. If f of x is continuous on the closed interval from a to b, then there exists an absolute max and an absolute min on that closed interval from a to b at either x equals a, x equals b, so at the endpoints, or any value on the open interval from a to b such that f prime of x equals 0 or is undefined. So if you have a closed interval that's continuous, the max or min is either going to be at the endpoints or it's going to be at where the derivative equals 0 or is undefined, the critical points. And then we can check it. So this is one that comes up a lot, especially in free response. So let's see if we can get through a little bit of this. 10 minutes already. Okay, I'm getting through this. So it says, picture to the right is the graph of the function cubic blah, blah, blah. On the closed interval, -4 to -1. Use the graph to answer the questions. Identify the absolute max or min from -4 to -1. So -4 to -1 is this whole graph. We can look at the graph and see the maximum is the highest point on the graph, which happens to be at 2 places again, right? That's going to be at -4, 6, and also at -1, 6. And the absolute minimum, the absolute lowest point on that graph is this endpoint right here at 1, -14. Okay, sorry. I did this. I re-recorded this graph or this video, and I did the exact same thing. I did this for this bottom one here, right? These answers should go down here. Because I just did this for -4 to +1, which is the whole graph. But this problem is asking me from just here, right? So just for this part of the graph, from -4 to -1, well, the good thing is that the max is still the same. This is still the highest point, -4, 6, and -1, 6. But now the minimum, if I'm just looking at this part, the minimum is right here at -3, 2. Again, really nice when they give you the graph to look at it. But what we want to do is I want to show you how we can do this without a graph, because they're not going to give you a graph on the test. So it says, use the extreme value theorem to locate the absolute extrema on these values. Your algebraic results should match what we did up there. So step 1 is I need to find my derivative and find where it equals 0 or is undefined. So taking the derivative of this, I'm going to get -3x squared minus 12x minus 9. I'm going to set that equal to 0, and at the same time, I'm going to divide by -3 to get rid of those numbers in front. So that's going to become x squared plus 4x plus 3. And so when I factor that, I get +1 plus 3. So my critical points are at -3 and -1. Now here's what's different now that we're finding an absolute extrema, because I can't just rely on relative max and mins, because it might not be the highest or lowest value. So what I'm going to do is I'm going to take these numbers along with my endpoints, which happen to be the same thing, and I'm going to check into the original function to see what happens. So I'm going to see what happens when I plug in -4, because that's an endpoint. What happens when I plug in -1, which is an endpoint and a critical point. And then I also have to plug in -3. And because I'm looking for absolute extrema here, I'm just going to plug these in and see what happens. And if I plug -4 in here, you should get 6. And if I plug -1 in here on my calculator, I'm going to just kind of skip to the answer here. And if I plug -3, I get 2. How do I know which one is the max and which one is the min? The y values, which one is the biggest and which one is the smallest. And so if they ask you for the point, you give the whole point. If they ask you for the x value, just give this. But we get the same answers here, that we have an absolute max at -4, 6 and -1, 6. And we have an absolute min at the smallest y value, which is -3, 2. If we change the endpoints here from -4 to -1, I don't need to redo this part because the math is the same. It's still the same derivative. I'm still going to get the same critical points. So I still have to check plugging in -3. I have to check plugging in -1. And now I have to check these endpoints also, because those are what my possibilities say. I already did that over there. -3 was 2. -1 was 6. -4 was 6. And now when I plug +1 in, I get -14. So I look at this. This is my smallest number. So this is my absolute min at that point at 1, -14. And then this is still my largest point. So this is my absolute max at -1,6 and -4,6. But they put the graph there with it so we could kind of compare it with that. Okay? Okay. So if you go to the next page here, it says, does this apply? And this is where we're going to start, but you want to think about, does the if part apply? It has to be continuous on the interval from A to B. And so if it's continuous, then it applies. And if it's not continuous, then that means it can't apply. And so you can't guarantee that there's both a max or a min in that problem. Okay?